Good afternoon, everyone. Many thanks for registering for our second talk in the current SCItalks series trilogy on sustainability and regenerative agriculture. My name's Tim Reynolds. I am chair of the SCI's Public Evening Lecture Committee that organises SCItalks, and I'm really pleased to be chairing this particular talk. Regular attendees will know that we encourage questions for speakers after the talk, and you can pose a question via the Q&A session via the question box facility anytime during the talk, and I'll use that input to give questions to Harry. Otherwise, as you know, all attendees are in a listen mode, so you've been automatically muted by the Zoom technology. So today's talk is from Dr Harry Langford, who's an environmental scientist at an agri-tech innovation specialist who focuses on advancing crop productivity in a sustainable way. Harry has a research background in biological aggregates and soil health. His innovation work spans everything from environmental sensing to controlled environment agriculture and low carbon fertilisers. At the Agri-Tech Centre, Harry brokers and shapes collaborative R&D across the agri-food supply chain, translating science into product development to deliver sector-wide sustainability gains and business growth. Harry also leads on open innovation at the Agri-Tech Centre, uniting stakeholders to co-create rigorously assessed solutions to pressing challenges. Harry's talk today hopefully will demonstrate regenerative agriculture requires scalable, science-led innovation as much as it does enthusiastic farmers with an appetite for change and a curiosity to experiment. And he'll showcase some of the collaborative R&D that UK Agri-Tech Centre is currently involved in. Over to you, Harry.
So thanks very much. So pleasure to be here this afternoon on the webinar. As Tim mentioned, I am the Interim Innovation Director at UK Agri-Tech Centre. And for those of you who don't know the UK Agri-Tech Centre, we aim to accelerate the innovation and adoption of agri-tech solutions by directly supporting agri-tech businesses to develop those solutions and connecting them across the ecosystem. So we really have a partnership approach to working with other organizations in that ecosystem, and we're looking to build and maintain knowledge of the critical agri-tech innovation barriers and gaps across that ecosystem to enable businesses to develop strong partnerships and to deliver impact for the agri-tech sector. And we do that in three principal ways. We provide direct agri-tech business support to SMEs and ventures that are looking to develop new solutions in the area, to help them to access skills, expertise and capabilities that they might need to develop their agri-tech innovations. We also have a test, trial and demonstrate function. So we have a number of facilities that allow innovators to test and integrate their solutions into real world or commercially representative innovation and production environments to improve the successful development of UK technology. And we also support with sector growth so trying to understand, as Tim mentioned, via open innovation, for example, some of those critical challenges that are preventing new innovations getting to the market, and see whether we can help to break down some of those barriers. And just very briefly, before I go into the regenerative agriculture, just wanted to sort of outline really that we have a national presence across 43 research and innovation facilities that are located at research institutes and universities across the country, and a 22 strong commercial farm network. And that really allows us to focus our own individual expertise and our ecosystem, so our network of over 600 stakeholders, to really drive innovation in the agri-tech sector. So before I talk a little bit more about regenerative agriculture, I just wanted to drop one slide in on the context for innovation, because when we consider good ideas that are coming out of the research base, coming out of universities, it's really critical that we understand the farm business context for innovation in this space. And that is that efficiency gains are key. So in the 70s and 80s, those efficiency gains were primarily output driven, but more recently it's input reduction and output maximization that's likely to make an innovation successful. And this really marks a shift in mindset towards sustainable productivity, and regenerative agriculture is one of those areas to benefit. You can see some really nice examples, graphical examples there, if you consider the price of a modern tractor versus the inflation adjusted wheat price. You can really see the fundamental shift in the cost of capex inputs into that farming system versus the price of outputs, and that's really what's driving this this change towards reducing inputs and maximizing those outputs. So what is regenerative agriculture? I'm sure I'll just do this briefly, but I'm sure many of you are already aware, but it's broadly following a number, around 5 key principles to when undertaking agricultural production, and that is to minimize soil disturbance. So a lot of that is around no-till direct drilling of crops, or minimizing tilling down to a minimum till approach, and then there is constant coverage, maintaining a constant coverage, and that can be by incorporating cover crops in between cash crop cycles, or it can be by actually trying to maintain a living understory of cover crops, or a broader lay within the field that is drilled into and recovers back after harvest, creating a full year of living roots within that system. It's also around diversity. So that's not only diversifying the rotation so that there are more crops included within it, but it can also be diversifying the plants within a field as part of the production cycle. And that crop rotation can also include integration of livestock and therefore integration of organic manures and fertilizers into that production system. So why are we doing regenerative agriculture? Well, broadly, it's to try and address some of the critical challenges that the agricultural sector and the UK and globally soils face. That is principally soil degradation. So around a third of UK soils are thought to be degraded in their health, and that does have an economic cost in terms of restriction of yields within production. Also pollution. So a number of water bodies in the UK fail to meet good status, and a proportion, around a quarter of that, is correlated with diffuse pollution and sediment deposition from agricultural activity, because our soils can't hold on to those in-field nutrients that are then creating pollution in riverine systems, and also net zero. So UK agriculture is responsible for between 10 and 12% of greenhouse gas emissions, depending on what report you read, and that's dominated by methane and nitrous oxide. And all of that is requiring that mitigation by 2050 as part of the government's net zero pledges. So what can regenerative agriculture do in this space? Well, it can help to restore soil functions ultimately. So just created this schematic to show that some of those founding principles of regenerative agriculture around minimizing tillage and maintaining soil cover, improving nutrient circularity, minimizing chemical inputs, can drive improved soil health. And what that means is improved capacity of the soil to adsorb chemicals onto its surface, improved structure of the soil to allow for more efficient water transit and holding, and improved cycling within the soil, so more biological functionality. And that can increase in the transformation of these chemistries, improving nutrient uptake efficiencies, scavenging of micronutrients within the soil, and all of that benefits ultimately plant production. Just segueing into an example here of regenerative practice within our farm network. So Overbury Farm is a 1,600 hectare mixed farm that's been conducting regen ag for over 10 years, and it's part of our own farm network. It's also a leaf demonstration farm. And some of the things that we do on our farm network sites are to host field trials and support demonstrations, like with UAVs for mapping, unmanned aerial vehicles, that is, for mapping within the field, for example, weed burden within no-till systems, and also getting direct end user feedback on new technologies. And so Jake at Overbury Farm is quite an interesting exemplar for regenerative agriculture, because he's really majored on that no-till direct drilling into a green cover crop understory, which is enabled through a lot of technology, ultimately. So GPS guided precision machinery and UAVs for efficient input application and monitoring, and also advanced diagnostics for nutrients to identify inputs, deficiencies, and stress, so that when you are transitioning between a cover crop and a cash crop, you know how much inputs you need to apply. And you can also monitor, if you're applying biological inputs, you can also monitor the efficacy of that and any resultant stress within the crop. So Jake's a really good example of how what you have in regenerative agriculture is a sort of melting together of principle-based practice change and new technologies that are driving a more efficient and more sustainable production systems. And I wanted to put this in the broader context of agri-tech innovation as well, and just highlight some of the main innovation opportunities that we see. And these are shaped from responses that we've got back from a stakeholder project that we're working on. We're actually publishing it tomorrow So you've got a tiny bit of early insight prior to production tomorrow, and as part of that future-facing look at innovation in arable and horticultural production, stakeholders told us that there was a significant opportunity to enhance productivity sustainably, and that they see advances in precision agriculture enabling farmers to optimize inputs, and they see that actually combining with climate-resistant varieties and new amendments to improve soil health to mitigate those extreme weather risks that agriculture is now facing. And then innovation in monitoring and verification supporting the scale up of new and sustainable practices. So more specifically, we have been working with stakeholders to build up a picture, and we've actually now developed 4 principal pathways that the sector we're encouraging the sector to progress around. So those are intelligent agriculture, so combining enabling technologies like robotics with sensing and AI to maximize efficiencies in production systems. That is biotechnology for resilience, which is focused on developing new crop protection products to enhance the crop protection toolbox, but also new crop varieties and citing those within integrated crop management programs. And in regenerative solutions in particular, we're looking at precision technology for regenerative agriculture, be that drilling or application, and new biological inputs into these systems, because a lot of regenerative farmers do have a desire to transition away from chemical inputs wherever possible, and also more novel input technologies into those systems. And then the final one is looking at diversifying production, and some of that is in field by breeding new crops for more diverse systems. So lupins, for example, is actually an old crop that we've been working on trying to bring back into production systems. But also in this diversifying production stream, we're looking at controlled environment agriculture and vertical farming, and creating more integrated food systems. Now, across all of these innovation areas, it's on-farm decision making that's the key interface for this technology, and that's no different for regenerative agriculture. Ultimately, farmers want a more resilient production system in the first place, and then they want technology that helps them to detect problems, decide on a strategy, and deploy a solution. And we can see that perhaps best exemplified in innovation in the sensing and measurement space. So previously, instead of using a more simple image-based observation system like NDVI, which is Normalized Difference Vegetation Index, and soil testing to make a decision at a field scale, we're now getting new technology and new innovations, for example, in hyperspectral sensing that you can do from a UAV, or actually most recently from a satellite, and that can take us towards a per plant level of decision making. So it gives you a much more precise level of information, and allow you to ask ultimately different questions before you might just be able to understand whether the crop was stressed. But now you might be able to understand the specific nutrient status of micronutrients in a crop, or the specific disease status of a crop, which allows you to ask different questions. And then moving on to precision application. This is another area of technology development that really is synchronous with regenerative agriculture. It's a technology development area that integrates between sensing, data, and AI, and also automation to deliver more targeted inputs in farming systems. So you have, for example, sensors that can plug into the front of tractors, like the Yara N sensor, which will give you live information on the amount of nitrogen within a crop. And that can allow you to, using advanced applicators, apply a bespoke amount of nitrogen to individual areas of that field, delivered via a smart control system. What it can also allow you to do is to apply different types of fertilizer. So traditionally you would have maybe a granule or a prill, like a solid type of fertilizer, or in some cases you would have a liquid foliar spray fertilizer. But actually some of the new inputs that are coming through are biologicals, like microbial products that are microbial suspensions. They're very sort of thick, turbid liquids. They have a different behavior, and that means ultimately that you need to innovate in order to apply them well in a regenerative context. So going on now to a few of our projects to exemplify some of the work that we're doing in this space. So thinking firstly around that precision machinery innovation pathway in the short term, some of the work we've been doing as part of the Potato Light project is looking at how we sustain potato production in future regenerative agricultural systems, working with a broad consortium that you can see there. And why are we doing this? So this is a great picture that really encapsulates the challenge. So this is current practice, which is to develop a deepened and destoned seed bed to achieve the yield and quality outcomes that are deemed necessary within a robust supply chain. But the number of passes and the depth of and intensity of that cultivation operation is detrimental ultimately to soil health. So we are trying to work across this, it's £824 million industry, to enable a more regenerative approach to root crop production in order to define a new best practice for potato cultivation that actually aligns with better with the rest of a regenerative cropping cycle. And we're doing that by ultimately developing and validating novel machinery, so destoning machinery and single pass machinery there, and then verifying the carbon footprint benefits of that new machinery, and then engaging and demonstrating that new technology and practice across the supply chain to ensure that confidence to adopt. Another example in the precision application space would be using novel diagnostics sensing technology to enable precision fungicide application. So in this project, we actually used Phoenix's low-cost multispectral imaging system, which you can see there in operation in the field, to detect disease spores early and to map them in order to create a spray map that will allow a more precise application of these fungicides. Fungicides, as with all inputs, are expensive, so you want to be using them in the most cost-effective way possible. So we worked with photonics in our lab, our digital phenotyping lab, to identify some of those spectral signatures for these pathogens to help photonics to autonomously detect and map that disease at field level. And then photonics use that data to train their own AI models, and ultimately they reduced the number of the amount of spray across the field quite significantly. So you can see that the red indicates the area that is not sprayed. So commercial sprayer versus the Spraybot project, you can see quite a significant increase in the amount of spray avoided within that field. Moving on next to biologicals, developing new biologicals for use within regenerative agriculture. One of the exemplar projects that we've completed in this area is working with BactoBio to look at new biofungicides for septoria, which is a major disease in wheat that causes quite significant, has the potential to cause quite significant losses. And they, BactoBio, have a proprietary platform called Baku that is discovers novel metabolites from previously unculturable microorganisms, and we help them by providing them with isolates of Septoria triticale from our national reference collection to screen against, in order that they could develop candidate species and metabolites to test in terms of efficacy within a controlled environment. And Rothamsted research supported us with this controlled environment testing of these new isolates in terms of their efficacy in preventing septoria development. So we deliberately applied septoria to these leaves and then looked for emergence of lesions. And you can see in the sort of bottom picture that there were some that essentially remained green that are more productive candidates for taking forward. And we've actually subsequently worked with CPI to help BactoBio scale up production of these metabolites and test them in a larger scale setting. And then moving on to sort of novel inputs side of things, some of the things that we do might actually be based around new plant-based technological inputs into a system. So this is a perfect example here, which is desist, which is a trap crop. It's a trap crop that is known to have efficacy against potato cyst nematode, which is a major root colonizing disease in potato crops. And this trap crop basically acts to draw the PCN towards it and keep it out of the main cash crop. What we did is to develop best practice for establishing this trap crop and guidance on how to manage it, and then efficacy testing in controlled conditions to support varietal development of the new trap crop species that Produce Solutions were developing, and then demonstrating this to growers and producing a grower guide to support adoption. And it was a very effective tool and a really good project that's gone on to have some long-term adoption of that product. And then on the other side, we could have something really rather novel. And an example here would be R-leaf. So this is a titanium dioxide photocatalyst. So it's essentially sprayed onto the surface of leaves, and it reacts with sunlight and nearby nitrogen compounds in the air to capture and convert those nitrogen compounds into nitrates on the leaf surface. And ultimately what this is doing is reducing reliance on synthetic fertilizers. And we've worked previously with R-leaf as an individual product, but this project was looking at combining this photocatalyst product with an endovite product that colonizes the stem and leaves of the plant and also fixes nitrogen biologically to reduce further the reliance on synthetic fertilizers, and to really understand how you optimize interaction between these novel input products and mitigate any stresses that they might exert on each other in order to maximize nitrogen use efficiency and soil health. And ultimately, we're doing this because these sort of novel inputs provide the opportunity to not only mitigate greenhouse gas emissions, but also sequester, which can deliver a greater contribution to greenhouse gas reduction. And yeah, we've currently just finished the major year of field trials for this product, and we're awaiting the sort of final results from that. In the meantime, the R-leaf product has been validated by SustainSet, and we're also working on a broader environmental assessment of the product to conclude that project. So yeah, I think that's brought my slides to a close. I think that hopefully that was an interesting overview of where technology and practice can really work in synergy together to drive more productive and sustainable outcomes in a regenerative agricultural context. Thank you very much for listening.
Okay, thank you very much, Harry. Yeah, that's very interesting. I mean, it's a funny thing. The last example with, I mean, titanium dioxide for me is a sunscreen, but I guess it's being applied at such a low level that it's not blocking anything. It's not having an effect on yield in that way. And I guess the benefits outweigh anything that might come from titanium oxide. I mean, it must be a low level. It's not, you're not sort of smearing a sun cream on the on the plant surface, I guess. Yeah.
No, it is, yeah, obviously a much lower
Yeah.
level of application versus your traditional sunscreen. Yeah.
Yeah. You'd hope. Yeah. Okay. Yeah, we have a few questions coming in. And the other thing that struck me going through this, I mean, for many years I was involved with things like Galileo and Copernicus, and went to a number of agricultural shows where I was looking at various tractors, and I was brought up in the countryside, and the modern tractor compared to what I was driving when I was a youth, let's say, is a technological marvel. Really, it's quite amazing how it's come on, and you're struck how it's really the sort of the model automated driving. I mean, they were demonstrating you don't really need the driver. It was a hands-off sort of application. This is probably a decade ago, so before the more advanced spectral analysis came in. But I mean, just that sort of concept of less is more in terms of application of fertilizer and fungicide, etc. And the inputs coming up from a satellite rather than the farmer's sort of general observation was quite very interesting. And I guess it's a continuing evolving area. Yeah.
It absolutely is, and we were involved alongside Harper Adams University with quite a few years ago, probably 5 or so years ago now, the hands-free hectare project, which looked at autonomous machinery to conduct a full cropping cycle without an operator entering the field, which was a bit of a showcase of it can be done. Realistically, what a lot of the innovators in that space have been working on in the subsequent 5 years is how to make that affordable from a capital perspective, and also how to ensure that, from an operational perspective, you get the precision that is required.
Yeah. Okay, well, we have a few quick questions coming. The first one we have here is from Sarbajoy Saha, who's actually originally from Bangladesh, but currently at the University of Westminster, and SCI College of Scholars member. See you tomorrow. And the question is, it's a reasonably long question, but in regenerative agriculture, the principle is to apply biological and chemical-free pesticides or fertilizer use for sustainable farming. Textile companies often release a lot of hazardous chemicals and wastewater into surrounding agricultural soil and water. The question is thinking about bio-indigo production also produces some wastewater, which is not as harmful as textile wastewater. And the question is there any opportunity to use this innovative idea within the point of resilient biotechnology, wastewater from bio-indigo, so microbially produced indigo from bacteria on agricultural soil to improve soil fertility or productivity? Well,
I mean, I would love to know a little bit more about the compound to be able to be specific, but what I would say is that there are a number of innovators that are working with what would have previously been considered waste streams from either the agricultural production system or adjacent production systems like forestry, mining, and other manufacturing waste streams, and repurposing those by typically extracting or locking certain nutrients into that product to create a fertilizer or a pesticidal product. And there is some really sort of interesting opportunities in that area, and what needs to be overcome is the challenge around the potential for unintended consequences, because what we see is that those sorts of technologies, unless you can be very sort of robust in your verification, it's difficult to de-risk adoption by the farmer, because ultimately farmers are taking on quite a lot of the risk within the supply chain in terms of production, and they would see that sort of technology as there is a risk for a compound that I don't want to enter my farm and to cause me problems that I don't I don't yet know or don't yet realize, but maybe after applying it for a few years, it will become a problem. So
Yeah,
there
yeah,
are some adoption barriers to innovations in this area, but there is some really big opportunities as well. So I see it as a fruitful area for further progress.
yeah. I guess it's a thing about sort of having a contained trial is which is never easy, I guess, or something that you can really control before it's unleashed on the countryside, so to speak. I guess a question from Sharma Barman, who's also coming in from from Bangladesh, which sort of is, what kinds of environmental compliance are you following in regenerative agricultural practice? I mean, is there a sort of a set of compliance guidelines or?
So there are some ISO standards that are associated with regenerative or sustainable practices. There are also um, retail, like supply chain standards so British Retail Consortium or Red Tractor or similar sort of standards that exist across the space that essentially operate in a similar sort of way, asking you to adhere particular to particular standards to meet a particular classification.
Yeah. I have an anonymous question in terms of the productivity. I mean, so wondering whether are we training sustainability for short-term productivity, or this is looking at a longer-term process.
No, I don't think so. I don't think
Okay,
so.
yeah.
I ultimately on the investor side, when investors are looking to invest in these businesses, these SMEs that are creating new innovations in the space, they will be asking for um, proof of sustainability outcomes,
Mm,
but also um, proof of economic outcomes, both from a productivity perspective, but also from a cost benefit return on
yeah,
investment, farmer payback period perspective. So both are really taken into account when these innovations are developed, because otherwise they won't be easily scaled or adopted ultimately within the farm system.
yeah. I mean, I say with all sustainability work, it's always those three P's: planet, profit, etc. I mean, I guess in the whole evaluation, you'll have those financial considerations, but also is there we're looking at what uh, the environmental evaluations, obviously, and also sort of social return on innovation, on investment. And I guess it's a big sort of a balancing act, I guess.
Yes, absolutely. I mean, some of the most widely adopted
Mm,
innovations to date have been innovations that not only save farmers money, but also save farmers time,
mm,
because actually that social balance is actually really important. And farming is quite it's quite a hard job
yeah.
ultimately, and
Yeah.
requires you to get up early, work late, do, especially during harvest and things like that. So anything that can reduce that time and make your time more efficient in terms of its application is really valuable in terms of that work-life balance for the farmers. Absolutely.
Okay. A question for Sylvie Reed. Thanks for the thoughts on key innovation areas. And she asked, in your experience, what do you think is the key for successful collaborative partnerships to deliver the intended goals and benefits? for people and planet in your area?
It's tricky to be
Yeah.
specific because there are a number of different types of partnerships that exist and work well. I think what I would say is that the the sort of outcomes and impact that the partners are trying to achieve should be aligned. If they don't have the similar sort of higher level ambitions, it's going to be
Mm.
a difficult partnership to develop and deliver on. I think the other on the um, swing side of that is also around knowing what role you play. One of the things that we do when we are building consortia for grants or bringing companies together, small or small and large companies together, is try and get really definitive about the role that each partner will play in delivering the project or program, because that is where you get communication breakdown when the roles aren't defined clearly enough.
Yeah, yeah, yeah. I mean, I must admit, I think that some of the project you demonstrated obviously were have got quite impressive partners all along the supply, but the innovation chain, let's say. I mean, right from basic research through to partners who can clearly deploy and have a real commercial, like McCain's, for example, in the potato project. I mean, it's in theory whatever happens can go into the market fairly swiftly, rather than the usual sort of delay, perhaps, from innovation to actual implementation, let's say.
Yes, absolutely. That's the idea. And we're also involved with the Adopt program, which is looking at giving farmers access to grants to specifically deploy new technology
Uh-huh.
and assess their viability for their own farming system and context. So yeah, we act in a supporting role to that program, and but yeah, more generally, we are trying to take technologies through from that sort of conceptual stage right the way through to adoption and overcome some of those main hurdles, those main values of death that
Mm,
businesses experience.
yeah.
Firstly, in terms of being able to get investment to scale, and then secondly, in getting that pipeline of early adopters to drive the technology forward and into implementation.
Yeah. Okay. Yeah, interesting. Maybe a final question we have here at the moment. What are the considerations about I guess food safety? Almost that's primary concern on the output, I would imagine, is that obviously you don't want to be in any way, I guess, uh, bring any issues into the final product through innovation. So I guess that must be a prime consideration.
Yes, it absolutely is. In in this context, it's probably a really good example as well of where we exploit partnerships
Mhm.
across the ecosystem, because we're not food safety laboratories at the end of the day, but we work really closely in terms of new products that are coming through with organizations like the Food Standards Agency or CRD, and we also engage with the supply chain as well. So either processors, wholesalers through to retailers, so that they can apply their food safety lenses onto the new innovations that we're helping to bring through the system, so that we can make sure that they are fit for purpose. But yeah, we don't do it ourselves.
Okay, I'll get one final question come in, which is a question about career opportunities in your area for biotechnologists in sectors such as soil fertility, crop production, food quality, etc. Yeah, I guess it's a growing
Absolutely.
market, literally.
Yeah, it is. So it is a very buoyant subsector, and if anyone's seen the latest government modern industrial strategy,
Yeah.
you'll notice that agri-tech is mentioned as a frontier industry within advanced manufacturing, and so that's been really positive to get that government support as well. That this is a really big industry with a lot of potential to transform via innovation. So I would only see the opportunity space expanding in the near term.
Okay. Yeah. Good news. Yeah. Okay. Well, I think we're going to call bring the Q&A to an end now as we're approaching our appointed hour of ending. So great thanks to Harry for an excellent presentation and extended Q&A, I would say. And thank you all for attending the seminar. A quick reminder that our third and final SciTalk in this trilogy is happening on the 10th of December, and the focus will move to balancing nutritional health and climate co-benefits in the National Dietary Guidelines with Dr. Pauline Scheelbeek from the London School of Hygiene and Tropical Medicine. So that's on the 10th of December. So it's a little later than normal. We usually have it towards the end of November, our third in this sort of the autumn trilogy. But yeah, just in time for Christmas. So do come along to that. I think it'll be slightly different, but nevertheless interesting. And of course, if you're not already an SCI member, I invite you to consider joining. It's a very friendly space to be in, and we cover a wide range of science and technologies. Otherwise, thanks again to Harry and to everyone for attending. Goodbye, and hopefully see you again in December.